Hello everybody. With that introduction of linear algebra and matrix operations, now it's time to cash in all these IOUs and really have a look at applications of linear algebra in general. It has huge impact in engineering, in social sciences, in finance, in analytics, linear algebra as a subject. And in this video, I will be looking at a practical application of linear algebra in terms of asset pricing. So the way we price securities in finance, one of the methods at least, is based on what we call as the no arbitrage principle. All right, so this is the pricing principle that I will be using. No arbitrage. As usual, first I will go over an example. First I will solve it paper pencil, and then we will learn how to solve that very same problem using Microsoft Excel basically. So we are going to use the no arbitrage principle, which basically tells you that when you price securities, the security prices must be such that there would, at the end of the day, there should be no arbitrage opportunity. Right? So arbitrage means you can benefit by buying or selling the securities. And so there shouldn't be any systematic way of doing it. The reason for that principle making sense is because if the assets were mispriced, by buying and selling you could have made profit out of it, then when you think about it, before you even made that strategy of buying and selling so that you make an arbitrage profit, other smart investors would have seen that a long time before you've seen it, right? Today there are algorithmic, so there are machines which do trading. We call this algorithmic trading, and there should be no room for arbitrage. So you shouldn't be able to, even if, all right, let me change my statement, even if there's a potential for a gain, those gains will not be long lasting. In that sense, this concept reminds us of the idea that in a perfectly competitive world, companies will end up earning zero economic profits. So in practice, so this is a concept which is very similar to that. So this is the principle that I'm using, and for that, what we do in general is to construct models. So the simplest model that you can imagine will be a two-period model. So this is the model that I will be working on, a two-period. In upcoming videos, I will also show you examples of three-period models and so on. But for the time being, we have a two-period model. Really, the time periods are time zero, which is the present, and t equals 1, which is the future. Well, the present is deterministic, meaning we know everything there is about the present. Asset prices are well known in the present. The uncertainty lies on the future at t equals 1. And to capture that uncertainty, we assume, again, our model assumes two states of the world in the future time, of the world at t equals 1. So at t equals 1, there are two states. You guys can call it, for instance, S1 and S2. So these are the two states of the world at time t equals 1. All right, so the timeline is very simple. We have a timeline here, time 0, time 1. So this is our timeline in real, so timeline. So the present is deterministic, nothing uncertain about the present. However, the future is uncertain. Because of the uncertainty of the future, it will have an effect on asset prices today. All right, so let's have a look at that. So let's have a model where we have two securities, two financial assets, or securities as we would call it, financial assets. The simplest two that I can imagine would be stocks and bonds. All right, a stock priced at S0 today, and again a bond So that's our first security. The second security is a bond which is priced at B0 today. All right. So what kind of uncertainties are there related to those two securities? It turns out the whole uncertainty is on the stock. The bond is has a certain outcome, and the way we will do it is the following. In order to clarify the whole thing, let's go ahead and work on an example. All right, so here is our example. So I will make up some numbers here so that we understand the storyline and explain how we can construct a very, very simple model to price financial securities of any sort, for that matter. So in our example, let the stock currently be priced at $100 and the bond is currently priced, say, at $90. All right, and well, we are contemplating on the future value of those securities, and it turns out that that stock that we have in front of us right now has a value of, depending on the state we will be in next year, which we don't know what it will be. In state 1, stock will either have a value of $135 if in state 1, if state 1 realizes, right, i.e. S1, or the stock price will decrease in value if turns out that in the future state 2 realizes, i.e. S2. So today we do not know what the future will be. The only thing we know about the future is it will be either one of the two states, either S1 or S2, either normal economic conditions or depression, for instance, as an example, or recession. So if state 1 realize at time 1, we know that the stock value will go up and it will be $135. So it's higher than its current value of $100, right? So you guys can see that. Or if state 2 realizes, our stock price will go down in value to $90. That makes sense. And then we need to also explain what's going to happen to the bond security. Well, B1, it turns out that the value of the bond will be $95 if state 1 happens, if in state 1. And guess what? Still $95 in state 2. So regardless of the future state, the bond promises $95. The value of the bond will be $95. So if you invest $90 today, you are guaranteed to be paid $95 a year from today, basically, right, in state 2. Okay, so far so good. And now the key idea is to be able to, based on these two givens, to be able to price all the other securities. So we are in a sense assuming that these two securities are correctly priced. Now, assuming that the prices of these securities are the way they are, both their current prices and the future prices, how can we price other securities? So let me go ahead and present 3 different securities that we will try to price, basically. So the first security is the following one. Let me write the questions. So questions. So I want to value the following securities. Well, the first one is and the question is the following question. Actually, let's write it as a simple question, I guess. Question: what should be or is what should be a fair price for each of the following securities, and or financial securities or assets, and the name asset pricing, right? So that's why we call that asset pricing. It is one of the main areas of study in finance, basically. So what is the price of the following securities? The first security turns out to be a bond security paying the bond is paying $110 in all states, in all future states, in all states. When we mean all states, what we mean is state 1 and state 2 in t equals 1. All right, so the second security is another stock paying, well, that stock is paying, it turns out it pays $65 in state 1. It promises to pay $65 in the future state 1, and well, significantly less, let's say $40 in state 2 at time t is equal to 2. T is equal to 1. The t equals 1 is the future state, right? Future time. Maybe I should have just wrote it as, instead of saying t equals 0, t equals 1, the present and the future, right? Present and the future. It's probably, well, anyhow. So when we talk about states of the world, we mean states of the world in the future. So in this case, the future is represented by t equals 1. All right, so that's the second security. We have, it turns out, 2 more securities that we want to value. The third security for which I want to find a fair value is a call option. And I will talk about what a call option is when we go over this problem, with a strike price of say $100, of $100 at t equals 1, basically, at the future. In the future, it has a strike price of $100, and we will explain what that means. And finally, number 4 is a put option. Put option, that's an option, with a strike price of $110 at t equals 1. So these 2 options are associated with the original stock. So as you guys can see, I don't want to confuse, but look at that, where we have another stock. So let's call this stock that we want to price in the second question as XYZ, and the original stock that was given to us, for which we know the current price and the future prices, let's call it stock ABC. All right, so ABC is the original one. So when we talk about options, what we mean is option associated with a stock. In this case, for question 3 and 4, those options are associated with stock ABC. All right, so these are the options relating to where the underlying security is stock ABC, given in the original wording of the example. All right, so you might say, wow, so this looks like a very hardcore finance problem, right? Asset pricing problem. So what is the correct approach? It turns out there's a very simple, very intuitive approach based on that no arbitrage pricing principle. And the idea is, turns out to be something called state contingent claims. State contingent claims. And the idea is the following. So and this is, by the way, this has earned a Nobel Prize to 2 financial economists during the 1960s, Kenneth Arrow and Gerard Debreu, for really inventing these claims, which are extremely natural, and they are the following. So those state contingent claims are the following. So claim 1, so this is the first state contingent claim. If you guys want, let's just call it SCC. SCC1 is a claim which promises its owner $1 if state 1 realize $1, and $0 if the state of the world, in the future state of the world, is S2. Does that make sense? $1 if state 1 realizes, and $0 if state 2 realizes. Versus another state contingent claim, which is the opposite. It promises $0 if S1 and $1 if S2 realizes. And that's the whole point. So for us to price real life securities like the ones in the question 1, 2, 3, 4, first we need to price these state contingent claims based on the given here on this example. So we already know the price of 2 securities, both current and future prices for stock ABC and that bond. And based on these, we will derive the state contingent claims, the prices for these claims, the current prices. And then, based on these state contingent claim prices, valuing these securities 1 through 4 will be extremely simple. Now, this is the simplistic case where we have two future states of the world. So what we will do in the following video will be a little bit more complicated model where we have 3 future states of the world, and so on. It's very easy. Once you understand the main idea behind this topic, then the rest is very straightforward. All right, so how do we find prices for these state contingent claims? So how much would you pay for a financial security called that SCC1, which promises to pay you $1 if state 1 realizes in the future and $0 if state 2 were to realize. And we are not given any, we don't have any idea of regarding which of the 2 future states is more likely. The only thing we know is the model made it clear that here is the timeline in front of us, the present and the future, and it turns out that the uncertainty related to the future is we know that one of 2 states will happen in the future, state 1 and state 2, normal economic conditions versus say a recession, for example. And so well, it turns out the idea is the following: we are going to use this no arbitrage principle to construct a synthetic portfolio which will give us the exact same payoff as the stock did in this example, and we will do the same thing for the bond. So the stock, once you pay $100 today, promises you $135 in state 1 and $90 in state 2. So in state 2, this is equivalent to purchasing 135 state 1 contingent claims and 90 state 2 contingent claims. Let me explain what I mean. So if you were to purchase 1 state 1 contingent claim, that would promise you $1 if state 1 realizes and nothing if state 2 realizes. What if you purchased 1 state 1 contingent claim and 1 state 2 contingent claim? Well, you will receive $1 if state 1 realizes and $1 if state 2 realizes. Why is that? Because the 1 state 1 contingent claim that you purchased promises $1 in state 1 and nothing else in state 2, and the 1 state contingent claim 2 that you purchased promises $0 in state 1 and $1 in state 2. So if you guys want, let's just go ahead and construct a table. So let's have a look at the security. A table with 3 columns, state 1 and state 2. And let's have a look at what will be the promises of each of these securities. For instance, if I purchased 2 state contingent claim 1 or state 1 contingent claim, let's call them state 1 contingent claim and state 2 contingent claim. There we go. S1CC and S2CC. There you go. So 2 S1CC. If an investor purchased 2 of these securities, state 1 contingent claims, 2 of them, how much payoff will he get? Well, he will get $2 in state 1 and $0 in state 2. Why? Because state 1 contingent claims only give you a payoff if state 1 realizes and nothing if state 2 realizes. This is the future, right? So this is the future. We don't know the future. The future is uncertain. That's why we are devising this table, these models, to try to see the pricing of securities today, because their payoffs in the future are different. How about another security which is consisting of 3 state 2 contingent claims? Well, that security will certainly pay nothing if state 1 were to realize and $3 if state 2 were to realize. How about another portfolio of securities consisting of 1 state 1 contingent claim and 3 state 2 contingent claims. State 2 contingent claims. Now this one is interesting. So it is made up of 2 securities. 1 unit of state 1 contingent claim and 3 units of state 2 contingent claim. The 1 unit of state 1 contingent claim will pay off $1 if state 1 were to realize in the future, and nothing else in state 2. And the other one, the state 2 contingent claim, will pay nothing in state 1 and $3 in state 2. That's it. So you guys see? So if you want to replicate the stock 1 or ABC stocks promises $135 in state 1 and $90 in state 2. Let's think about it. $125 if state 1 were to realize and $90 if state 2 were to realize. So how many state 1 contingent claims, 135, not 25, sorry for that, 100. So how many of the state 1 contingent claims and state 2 contingent claims should I purchase so that it will give me exactly the payoff of that stock? So this is the promise that the stock gives us, right? If I purchase that stock ABC promises me at year 1 this much payoff, right? Wait a second, I can get the exact same payoff by just purchasing 135 state 1 contingent claim and 90 state 2 contingent claims. Do you guys see that? And that's pretty much it. So the two are exactly equivalent. So therefore, if you want to price it, the pricing will be the following. The current price, let's say that the current price for the state 1 contingent claim is P1 and the current price for the state 2 contingent claim is P2. So what it means is, today, how much would you be willing to pay for that state 1 contingent claim, which promises $1 if state 1 were to materialize and $0 if state 2 were to materialize. And P2 is the price of a state 2 contingent claim today, and the price is based on this security which promises that state 2 contingent claim, which promises $0 if state 1 were to realize and $1 if state 2 were to realize. I think everybody would agree that both P1 and P2 must be less than 0, right? Because the most that they promise in both of them is $1, and it is just uncertain if we would even be able to get that $1 or not. Do you guys agree that $1 you will only get it if state 1 realize? If state 2 realize, you will get nothing. So it makes perfect sense that P1 and P2 are priced less than $1. Now the good stuff. Now let's go ahead and replicate stock 2 like we did here. So no arbitrage principle. Let's do it. No arbitrage principle applied to stock ABC stock tells us that, well, yes, so currently the stock is selling for $100. So that $100 better be equal to what? That $100 better be equal to the price of 135 state 1 contingent claim, 130, but those claims are sold at P1 each, and 90 state 2 contingent claims, and this is how much. So 90 state 2 contingent claims, each one priced at P2. Do you guys agree? The payoff here of so this is the price of purchasing one stock ABC, 1 unit of ABC stock. And obviously this stock, we already know, promises $195 if state 1 materialize and $90 if state 2 materialize. So how can I replicate that? By simply purchasing those atomic state 1 contingent claims and state 2 contingent claims. Just purchase 135 state 1 contingent claim and 90 state 2 contingent claims and combine those two, like 225 securities there. Combined will give you exactly the same payoff as the one security that you purchased. All right, but then we can do the same thing for the bond. Now, in the case of a bond, the bond promises $95 regardless of the state. So if you want, let's continue this table here, $95 regardless of the state that materialize. So what can give the same output the same payoff as a bond which promises $95 regardless of the state which materialize? Well, it's easy. All I do is purchase 95 state 1 contingent claims and 95 state 2 contingent claims, and if state 1 were to realize, then only state 1 contingent claims will give you a revenue, and in this case 95 times $1, $95. And if state 2 were to realize in the future, again those 95 state 2 contingent claims that you purchased will give you that same payoff. So we can replicate no arbitrage, let's write that down, no arbitrage principle applied to a bond. So let's say this is again an ABC bond. So let's assume that this is the same company's stocks and bonds. All right. Those bonds are currently sold at 90. How much are they selling for? They are sold at $90. Sorry for that. Let's go back. Oops. There we go. All right. So one more. How about now? There we go. Okay, so they are currently sold for $90, and they promise $95 in the future, regardless of the state of the future. So currently they are sold at $90. So it's easy. All we need is 95 state 1 contingent claims and 95 state 2 contingent claims. Once we purchase 95 state 1 contingent claims and 95 state 2 contingent claims, those two together, those 190 different state contingent claims combined, they replicate the bond portfolio. But now look at that. You have two equations. This is equation 1. This is equation 2. This is just a simple system of equations which we can easily solve. Either you guys can solve with paper pencil or with Excel, right? So we just learned it in previous videos and solve it for P1 and P2. So indeed, if you were to solve these two, P1 comes out as, you can use for instance the substitution method. P1 comes out as $0.3275, and P2 is $0.6199. That's it. So state 1 contingent claims are significantly cheaper than state 2 contingent claims. So basically this security, this state 1 contingent claim, which is currently selling at 32 cents roughly, or 33 cents, promises $1 if state 1 were to realize and $0 if state 2 realizes in the future. That's the promise that state 1 contingent claim gives you, and this is the price. If you want to purchase that claim, which entitles you to $1 if state 1 were to realize, then you need to pay this. Or alternatively, you want to purchase a security which promises you $1 if state 2 were to realize and $0 otherwise, then you should purchase the state 2 contingent claim, which is currently selling for $0.6199. So that's pretty good. So how will these help me pricing the 4 securities in the question? Right, so those 4 securities. So let's wrap up with this video by quickly calculating each of those 4 securities. I claim that it is very easy to price these securities with the tools that we have developed. So let me just go ahead and open some. Actually, hold on. Let me just do it using my pencil because it's easier. All right, so let me just move this a little bit down so I have space to. Whoops. There we go. So let's see if I will be able to properly move this whole thing down. Well, kind of. All right, so let's answer the first question then. All right, so these are a different stock, XYZ, right? And a bond, XYZ bond and XYZ stock. So we have this XYZ bond, which is paying $110. It's a bond. So regardless of the state at time 1, at the future, state 1 or state 2 doesn't matter, it pays $110. Now this bond is a different bond than the one we have here, where we had $95 regardless of what state happens. So how much is this priced at? That's easy, because it promises $110. The price of this bond should be, well, I can replicate it by purchasing 110 state 1 contingent claims, each one selling at P1, and by purchasing 110 state 2 contingent claims, each selling at P2 today. But we already calculated those prices. So 110, actually, let me just factor out the 110, which is P1 plus P2, right? So 110 times, well, P1 we calculated came out as 0.3275, and let's just write that down, 0.3275, 0.3275 plus, and then P2 came out as 0.6199. And indeed, if you were to add them and multiply by 110, that would have given you $104 and I believe 21 cents. That's it. You just priced another security, just so simple. Asset pricing, after all, is not that difficult after all. Well, we should be humble in our assessment, because this is the simplest model that you can imagine, just 2 periods and 2 future states of the world, right? So obviously the model can become significant. We can make the model significantly more complicated by trying to capture the full uncertainty of the future. Instead of a 2-period model, we can create a 3-period model, and instead of just 2 states of the world at each time period, at each future time period, we can do 3 states of the world or 4 states of the world. Does that make sense? So the way, if you want to be more successful in trying to predict asset prices, fair asset prices, obviously the more complexity, the better you will be able to predict the price with more accuracy. However, the more uncertain, the more things you add into the model, suddenly the model is no longer you won't be able to solve it paper pencil, but you would have to rely on some machines, right? So Excel or those type of softwares. But that's reasonable. All right, so we answered the first question. Now the second question, and for that, let me first again take that one down a little bit. There you go. Okay, perfect. So question 2 and 3 and 4, let me just slide it down a little bit. Awesome. So we have this stock XYZ, that's the name of the stock, XYZ, and it is paying $65 in state 1 and $40 in state 2 in the future, right? T equals 1 means the future. So then the question is, how much should this security XYZ be priced at? Well, the price of that security stock in that case should be equal to, well, because it promises $65 in state 1 and $40 if state 2 were to realize in the future, well, I can simply replicate that by just purchasing 65 state 1 contingent claims and 40 state 2 contingent claims, and that's pretty much it. So all I do now is just to plug in the same values. P1 was 0.3275 if I'm not mistaken, and P2 was 0.6199, and that's it. Just plug it in. Okay, let me just go quickly do it with my calculator in front of me. So 65 times 0.3275, 2129, I guess, plus 40 times, open parenthesis, 40 times 0.6199, close parenthesis, equals $46.08. That's it. So $46.08. So this stock is worth $46.08 today. And if state 1 were to realize, you will make a lot of money from it, because in state 1 that stock will be increased in value all the way to 65, and because you're only paying $46 today, you will make a profit out of it. However, if state 2 were to realize in the future, you will have making a loss, because in state 2 you will only get back $40 for which you invested $46.08 today. All right, so I think that makes sense. Next, let's go ahead and value those call and put options related to that company ABC. Oops, there you go. I want to make sure I get all of it. All right, so let's first drag this down. Awesome. Oops, ABC, the C just Okay, it didn't show up. So this is the call option for ABC stock. So what is a call option? Call option is a very simple financial security. It gives you the right. Call option is the right. Call is a right to buy, not an obligation. A right to purchase an underlying security. In this case, this is the ABC stocks, the original stocks in the original wording of the problem, this stock. So basically, it gives you the right to purchase the stock in the future. Because it gives you the right to purchase the stock at the future, the call option should be priced at a price above $0, right? So let me just give you the payoff of this call option. The payoff of this call option, so that we understand the nature of it. Payoff of this call option, because it has a strike price of $100. What that means is it gives you the right to purchase that stock at a cheaper price, at a price of $100. Well, when I say cheaper, I don't know if it's cheaper or not. In the future, we don't know the future yet, right? It is cheaper than $135 if state 1 were to materialize, right? And it would have been a profit for the person who owns that call option. Does that make sense? Because you have the right to purchase it at $100. So what you can do is you can purchase it at you exercise your call option, you purchase that stock at $100, and then you can immediately sell it at $135 because you know that that's the price of that stock if state 1 were to realize, and immediately making a $35 profit. So and as a result, we can write out the payoff of that call option as such. So the payoff of the call option will look like this: $35 if state 1 were to realize. Why? Because the strike price is $100 and in state 1 the stock is worth $135. How about the stock in state 2 is worth $90? What is the payoff that you will get from the call option? It gives you the right to purchase it at $100 in the future, where the future price of the stock is only $90. Of course, you will not exercise your right. Does that make sense? So you only exercise if state 1 happens because the stock price is higher and you want to exercise your right to purchase. But if you have a right to purchase at $100, that's the strike price, you will probably not exercise your right if state 2 were to realize, because you can simply go to the market in state 2 and purchase the stock for $90 only. So therefore, the payoff will go worthless if state 2 were to realize in the future. So do not exercise the call option. So how much is this call option worth, which has a strike price of $100 and the underlying security is the ABC stocks? Well, that's easy. So the price of that call option is simply equal to, you can replicate that call option by purchasing 35 state 1 contingent claims, each one priced at P1, and purchasing basically no state 2 contingent claims. You don't have to, because the payoff in state 2 from that call option is just nothing. So therefore the answer would be just 35 times P1, and we already calculated the price of a state 1 contingent claim was 0.3275, and if you were to multiply these two numbers, it would give you, I believe, $11.46. That's good. That's the third security that we priced today. So that's the third one. That was the second one we priced. And the first one we priced at a price. Oops, not that one. Sorry for that. Go back. Okay, there we go. This one. All right, finally, we're ready to price the very last security, which is a put option. A put option is very similar to a call option, except that the put gives you the right, is a right for the purchaser, gives you the right to sell a security. In this case, it gives you the right to sell the security at the strike price of $110. So as a result, the payoff, the expected future payoff of the put option is the following. So in the future, the put option, if state 1 were to realize, it gives you the right to sell the stock at $110. It kind of doesn't make sense, right? Because how can you exercise it? Exercising would mean first go to the market, purchase the stock at $135, and then exercise your right and sell it at $110. That doesn't make sense. You buy high and you sell low. So basically the put option goes worthless if state 1 were to realize, if state 1. So don't exercise your right. Don't exercise. Don't exercise your right to sell, right? Exercise. Versus, well, wait a second. If state 2 were to realize, we know that the underlying security, underlying stock, ABC stocks, is worth only $90. And now you have a benefit. What you can do is in the future state, in the future, what you can do, because state 2 realized and the stock is currently selling at $90 in the marketplace, you can go ahead and purchase from the marketplace at $90. And then because you have the right to sell that stock at $110, you exercise that right and you earn $20. You make a capital gain of $20. State 2. So in state 2, you exercise your right. And finally, as a result, the price of the put option is simply equal to, well, you don't have to purchase any state 1 contingent claims, but you need to purchase 20 state 2 contingent claims. So this one is gone. 20 times P2 is 0.6199, and 20 times 199, that gives you $12.40. And that was the last financial security that we wanted to price. Guess what? This has been like an introduction, a very simple, gentle introduction to asset pricing for you all. But this is a very legitimate way of using linear algebra, right? So financial models are always like this. So the part where we used linear algebra was when we solved this system of equations, those two, where we derived the state contingent prices, P1 and P2. And once we had those prices, we were able to plug them in and then to calculate the values of different securities. Look at that. All these securities, we are able to construct, equations which are linear. And that makes sense because they are linear in fashion, and so that's just perfect. So this is a wonderful application of linear algebra in finance. All right, so we will be going ahead and solving a couple other examples. The upcoming examples obviously will be much easier to solve because I won't have to explain the whole story again. So hope to see you guys in our next video.